Hey everyone, and welcome back for another deep dive. This time, we're going to be exploring something uh, pretty wild.
Oh, yeah.
The Janus Cosmological Model.
I love this one.
Have you heard about this one?
I have. Yeah, it's a fascinating one.
It is. It is. So, you know how we always talk about parallel universes?
Right.
Well, what if I told you that there might be a mirror universe right next to ours where time flows backward?
Yeah.
Pretty crazy, huh?
It's a wild idea.
It is a wild idea. So to really wrap our heads around this, we're going to be taking a deep dive into an article all about it.
Okay.
And get this. We're going to be tackling some really big questions.
Like what?
Dark energy,
Okay.
dark matter, the arrow of time,
Right.
and even the Big Bang itself.
Wow, those are some biggies.
Yeah, so get ready. It's going to be a wild ride.
So what I think is so interesting about the Janus model is that it really challenges our most basic ideas about the universe.
Okay.
You know, like how we assume there's only one universe.
Right.
This model says, nope, there's actually a twin universe, like a mirror image, and it's flowing in the opposite direction of time.
Okay, so imagine two universes, right? They're
Yeah.
intertwined,
Yeah.
but like we can't see the other one.
Right.
And ours is moving forward in time
Yes.
while the other one's going backward.
Exactly.
So does that mean like everything in that other universe is happening in reverse?
That's a great question.
Like a rewind button for the cosmos?
You know, that's something a lot of people wonder about.
Right.
The model itself doesn't really get into all those specifics,
Okay.
but what it focuses on is how these two universes interact with each other
Okay.
through gravity.
Ah, so gravity is like the bridge between them.
Exactly. And that interaction is where things get really interesting because according to the Janus model, that could be the key to figuring out some of the biggest mysteries we have about the universe.
You mean things like dark matter and dark energy? Like those invisible forces that seem to be shaping the universe.
Exactly. You know, like how galaxies spin way faster than they should based on the matter that we can actually see.
Yeah.
Well, Janus model suggests that that extra gravitational pull could be coming from, you guessed it,
The mirror universe.
the mirror universe.
Wow.
So instead of these mysterious invisible substances,
Right. Dark matter and dark energy.
it's the influence of a whole other universe tugging on ours.
Hold on. So instead of trying to find these elusive dark matter particles that everyone's been searching for,
Right.
we should be looking for the gravitational fingerprint of this backward-flowing universe.
Exactly.
That's a huge shift in perspective.
It is, and it gets even more interesting when you consider how this model, like, reimagines Einstein's equations of general relativity.
Because Einstein's theories, those are kind of the foundation of our understanding of the universe.
They are. They totally revolutionized how we think about gravity and the universe as a whole.
So how does the Janus model change those equations, if at all?
Well, instead of assuming that time, just flows in one direction, it uses a framework where Einstein's equations work, whether time's moving forward or backward.
Oh, wow.
It introduces this concept of time symmetry.
Time symmetry.
Yeah, where the laws of physics are consistent regardless of which way time's flowing.
Okay, so like the same rules apply, whether you're going forward or backward in time.
Exactly.
Yeah.
Pretty mind-blowing, right?
It is. It makes you think about time in a whole new way.
Definitely.
But if this model is right, what happens to the Big Bang?
Ah, the big question.
I mean, that's always been considered like the starting point of the universe, hasn't it?
Right, the big explosion.
Right.
Well, this is where things get really, really interesting.
Okay.
The Janus model actually gets rid of the need for that Big Bang singularity.
The singularity.
That infinitely dense point where everything supposedly began.
Right, right.
So instead of a sudden burst of creation from nothing,
Okay.
it proposes a symmetrical cosmos. No beginning, no end.
So no dramatic explosion. No, like, fireworks show to kick things off.
Yeah, forget the fireworks show.
Okay.
It's more like, imagine a gradual emergence, a continuous unfolding of space and time. Like a cosmic dance between these two time-reversed universes.
That's cosmic dance.
Yeah, and this gets rid of the need for that singularity, which has always been a bit of a headache for physicists.
It's like swapping out like a loud, explosive party with a smooth, elegant waltz.
Exactly.
I like that analogy.
It's a much more harmonious picture.
It is, it is. But how does a universe without a Big Bang actually evolve?
Right.
Does everything just exist, like, eternally?
Well, the Janus model suggests that both time directions, forward and backward, emerge smoothly as part of this balanced process.
Okay.
It's like a different way of thinking about the Big Bang Theory altogether, right?
Right.
It's a more harmonious, continuous view of how the cosmos evolves.
Okay, so we've got two universes, time flowing in opposite directions, and a cosmic waltz instead of a Big Bang.
Yeah, that's the Janus model in a nutshell.
It's definitely making me rethink, like, everything I thought I knew about the universe.
I know, right? And that's the beauty of exploring these new cosmological models.
Yeah.
They push us to, like, question our assumptions
Right.
and consider possibilities that we may never have even imagined before.
Absolutely. It's like suddenly realizing the universe is way grander and more intricate than we ever thought.
Totally.
And this whole concept of the two universes interacting through gravity.
Yeah.
Could that be the answer to the mystery of dark energy as well?
Oh, that's a great point.
We've always attributed the, like, accelerated expansion of the universe to dark energy.
Right.
But what if it's actually something else entirely?
That's exactly what the Janus model suggests.
Okay.
It says that what we perceive as dark energy might not actually be some mysterious force within our universe.
Okay.
It could be the gravitational influence of that reverse time universe pulling on ours.
Oh, so like a cosmic tug of war.
Exactly. A cosmic tug of war, subtly influencing the expansion of space itself.
That is incredible. So instead of some unknown exotic energy field,
Right.
it's the pull of another universe that's making the expansion speed up.
That's the idea.
That kind of rewrites the whole story of how the universe is evolving, doesn't it?
It does. It really changes our whole picture of the cosmos.
Yeah.
And it opens up so many new questions.
Yeah, like what are the limits of this gravitational interaction? How does it affect the formation of galaxies and stars? Are there other things we can observe that would point to this cosmic dance?
Exactly. There's so much more to explore here.
So let's dive into some of those questions and see how scientists are actually trying to test this model in the real world.
Let's do it. This is where things get really exciting. Because the Janus model isn't just some philosophical thought experiment.
Right.
It's a theory that we can actually put to the test.
Okay, I'm hooked.
Me too. Let's go.
But how do scientists even start looking for evidence of a universe that we can't see?
Right. It's like, where do you even begin?
Yeah, it seems impossible, like finding a needle in a cosmic haystack.
It's a huge challenge, for sure.
Yeah.
But the Janus model does give us some pretty interesting clues.
Okay.
So researchers are focusing on these, like, subtle gravitational signatures
Okay.
that might point to the existence of that reverse time universe.
Okay, like what kind of signatures? What should we be looking for?
Well, one big area of investigation is the cosmic microwave background radiation.
Ah, the CMB, the afterglow of the Big Bang.
Right, it's this faint radiation that fills the entire universe.
Yeah.
And the Janus model predicts that there should be specific patterns in this radiation.
Okay.
Patterns that wouldn't exist if there was only one universe.
So these patterns would be like, what, like a fingerprint?
Exactly. It'd be like a fingerprint of the gravitational interaction
Wow.
between our universe and the time-reversed one.
So scientists are literally searching for these tiny anomalies in the CMB that
right.
could only be explained by the pull of another universe.
That's exactly what they're doing.
That's some serious cosmic detective work.
It is. It is. And it's not just about finding these anomalies either.
Okay.
The Janus model also makes predictions about how matter is distributed throughout the universe.
Okay, how so?
Well, the gravitational influence of the reverse time universe should affect how galaxies cluster together.
Ah, so it would create patterns in the way galaxies are arranged.
Exactly. And those patterns would be different from what we'd expect in a single universe model.
So if we see those specific patterns, that would be a pretty strong sign that the Janus model is onto something.
It would be huge, like finding a piece of a puzzle that fits perfectly.
Yeah.
And the more pieces we find, the more confident we can be in the whole picture.
That's so cool. It sounds like we're on the verge of some really groundbreaking discoveries.
I think so, too. It's a very exciting time for cosmology.
It is. It is. But, let's talk about time for a second.
Okay.
Because this whole concept of a universe where time flows backward, it's just mind-boggling.
I know, right?
Does that mean, like, cause and effect are reversed in that universe? Like, a broken vase reassembles itself before falling off the table?
It's tempting to imagine those kinds of scenarios.
Right.
But the Janus model doesn't necessarily say that everything happens in reverse over there.
Okay.
It's more about the overall flow of time being opposite to ours.
Got it.
Like, think of two rivers flowing in opposite directions.
Okay.
The water molecules themselves aren't moving backward.
Right.
It's the direction of the flow that's different.
Okay, so maybe it's not like rewinding a movie,
Right, exactly.
but it still makes you wonder, like, what does this mean for our understanding of time itself?
Yeah, it really challenges our traditional view of time,
Right,
like this linear arrow pointing from past to future.
right, right.
Maybe there's a deeper level of reality where time isn't so straightforward.
It's like we're getting a glimpse behind the curtain of our everyday experience of time
Exactly.
and seeing something much more
And
profound.
much more mysterious.
Yeah, and if time isn't this rigid, one-directional thing, what does that mean for things like free will?
Whoa, that's a big one.
Yeah, like, if the future is already set in the reverse time universe,
Hmm.
does that mean we don't actually have choices?
That's a question that philosophers have been debating for centuries.
Yeah,
The Janus model doesn't really give us answers to these deep philosophical questions,
yeah,
but it definitely makes us rethink our assumptions.
yeah.
Like, maybe free will and determinism aren't mutually exclusive.
Okay.
Maybe there's a way to reconcile those ideas within a framework that allows for time to flow in both directions.
It's like the Janus model is opening a Pandora's box of philosophical questions.
It really is.
It's exhilarating,
Yeah.
but also a little bit terrifying.
I agree.
Yeah.
But even if the model turns out to be wrong,
Yeah,
just thinking about these possibilities, it really expands our understanding of the universe.
absolutely. It makes you realize how much we still don't know.
Exactly.
Yeah.
And how much there still is to discover.
It's pretty amazing to think that we could be rewriting the entire story of the universe.
I know, right?
We've gone from this idea of a single universe born out of a fiery explosion,
The Big Bang.
right, the Big Bang, to this possibility of a dual universe engaged in this, like, cosmic dance across time.
It's a huge shift in our thinking.
It really is. It's a paradigm shift of, like, epic proportions. And it shows how awesome science is, doesn't it?
Absolutely.
Yeah.
Our understanding is constantly evolving.
Yeah.
What we think is true today
Right.
might be just a stepping stone to a deeper understanding tomorrow.
It really makes you wonder, like, what other mind-blowing discoveries are waiting for us out there in the cosmos?
Oh, there are definitely more out there waiting to be found.
So let's say for a minute that the Janus model is actually confirmed.
Okay.
What does that mean for the future of cosmology? Like, what new paths of exploration would open up?
I mean, if we actually confirmed a reverse time universe,
Yeah.
it would be like opening a whole new chapter
Right.
in the book of cosmology.
Oh.
Scientists would have to come up with totally new tools
Yeah.
and techniques to study this mirror universe,
Yeah.
to figure out its properties
Yeah.
and how it interacts with our own.
So we'd be looking way beyond telescopes and particle accelerators.
Oh, yeah, for sure.
We'd need entirely new ways of even observing and measuring this hidden reality.
Absolutely. I mean, what would that even look like?
I know, right? It's hard to even fathom.
It's hard to say for sure,
Right.
but it would probably involve a mix of things like theoretical modeling,
Okay.
advanced simulations,
Yeah.
maybe even entirely new branches of physics.
Wow.
We might have to rethink our most basic ideas about space, time, and gravity.
To understand what a dual universe really means.
Yeah, to truly grasp the implications.
It's like we'd be venturing into completely uncharted territory,
It would be a whole new cosmic frontier.
where all the old rules no longer apply.
Exactly.
That's both incredibly exciting and a little bit daunting, wouldn't you say?
Definitely both.
But, that's what makes science so captivating, right?
It
It's
is.
this ongoing journey of discovery.
It is a journey, and it's always pushing the boundaries of what we know.
Well, I have to say, our deep dive into the Janus Cosmological Model has definitely left me with more questions than answers.
That's usually how it goes.
Yeah, but I think that's a good thing.
It is. It means your curiosity is sparked,
It has.
and you're thinking about things in new ways.
I am. It's really expanded my understanding of what might be possible out there in the universe.
That's fantastic. And that's really the goal,
To inspire that sense of wonder.
Yeah, to inspire wonder and encourage people to explore the mysteries of the universe.
Right, and the Janus model does just that.
It's such a good example of how even a single idea can really challenge our thinking.
And open our minds to new possibilities.
Exactly. So, to our listener, as you think about all this,
Yeah, as you try to wrap your head around the Janus model,
we want to leave you with this.
if there really is a mirror universe out there flowing backward in time,
What does that mean for you?
yeah, what does that mean for how you see reality, the past, the present, and the future?
That's a question that might not have a clear answer,
Right,
but it's definitely worth thinking about.
absolutely. The universe is full of surprises.
It is.
And I, for one, can't wait to see what other incredible discoveries are out there waiting for us.
Keep questioning, keep exploring.
And keep an open mind.
That's where the real adventure lies.
Couldn't have said it better myself. Thanks for joining us for another deep dive, and we'll see you next time.
See you then.